when b becomes a, that means whenever the lower limit b is equals to a, you are going to get integral a to a f of x dx is equals to 0. Now here, by changing the limit, minus sign will become plus, not this minus sign. Be careful dear students, outside by property 2. This is what the proof. Not only these two steps you are writing, you are going to prove this one, what I have proved in the last property, and then you are going to write accordingly. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. In the last session, we have learnt many problems on definite integral, dear students, that too especially by substitution method. In today's session, dear students, here we are having session number 21 and chapter number 7 called integrals. And what are the topics we are going to study under this session, dear students? Some properties of definite integrals. And dear students, this is very important. One proof they are going to ask you for your final examination in part D. And this is very important, dear students. One proof they are going to ask you in the final examination for part E. Okay, so or they can be asked for a proof of a 3-marker question. Understood? Now, let us move on to a property number 1. What they've asked, prove that integral a to b f of x dx is equal to integral a to b f of t dt. Just you have to change the variable, dear students. Here, I am taking the left-hand side. What is the left-hand side? Left-hand side, I am having as integral a to b f of x into dx. Isn't it? Now, here I am going to do the substitution as like, let x is equals to t. If x is equals to t, so differentiate this with respect to x. So, you are getting it as dx is equals to dt. Now, dear students, as soon as you do the substitution method, you have to change the limit of that also. So, here I am going to take it as when x is equals to 0, what about, see, when x is equals to not 0. So, when x is equals to a, what about t? So, when x is equals to a, t is also a, isn't it? So, when x is equals to upper limit is nothing but b, t is also what? T is equal to x, so t is also b. Take it as this one, which implies that integral when x is equals to a, t is also a. When x is equals to b, t is also b. Now, f of x I have taken it as t and then dx is nothing but dt. So, this proves your RHS. I hope you got this one. Therefore, we can write integral a to b f of x dx by changing the variable integral a to b f of t into dt. That's it. Now, we'll be moving on to the next property what they've asked. Prove that integral a to b f of x dx is equal to minus of integral b to a f of x dx. In particular, a to a f of x dx is equals to 0. Now, you have to prove that two properties also here. Now, let me take whatever the second fundamental theorem of the integral calculus says, that integral by second fundamental theorem of integral calculus says that integral a to b f of x dx can be written as f of b minus f of a. That means when you are taking this integral, you are going to get the answer in the form of capital letter f of x from the limit a to b. Applying the upper limit first minus lower limit next. Now here I can change this one as, which implies minus of. If I am going to take the minus sign symbol common, now I can write the minus is nothing but plus. So therefore you can have here minus into plus is minus, right? Again minus into minus is nothing but plus. So therefore you can have this will be is equal to, so if it is integral a to b f of x dx can be written as f of b minus f of a. Therefore, minus f of a minus f of b can be written as integral b to a. Lower limit will be b because minus sign, and upper limit will be a f of x dx. And this what the proof you are going to have it as. Now here, when b becomes a, that means whenever the lower limit b is equals to a, you are going to get integral a to a f of x dx is equals to 0. So therefore, when in particular, you can have in particular, when b is equals to a, we have integral a to a f of x into dx is equals to 0. And this is what the proof of that two property leads. Now we'll be moving on to the next property, DS. What they've asked. Prove that integral a to b f of x dx is equals to integral a to c f of x dx plus integral c to b f of x dx. Now, dear students, as like the second fundamental theorem of the calculus, I am going to write the left hand side as, see, according to second fundamental theorem of calculus, that is integral calculus, especially calculus, you are having integral a to b f of x, just now we have written dx can be written as f of b minus f of a. Similarly, by taking the right hand side, integral a to c f of x into dx can be written as f of c minus f of a, right? Similarly, integral c to b f of x into dx can be written as f of b upper limit minus lower limit as f of c. Now call this as the 1, equation 2 and 3. Now you can have adding 2 plus 3. Let us add this one. What happens to the condition? So adding equation 2 and 3. By adding equation 2 and 3, you can get it as, what is 2? Let us write first the left hand side, that is integral a to c f of x dx plus integral c to b f of x dx. Now let us add the right hand side. What is the right hand side? F of c minus f of a. That means integral a to c f of x into dx. So f of c minus f of a. Now you can add, so no need to take the bracket because you are adding means plus will be plus only, minus will be minus itself, right? So adding the next integral c to b f of x dx, which is f of b plus f of b minus f of c. Now ds, you can see there, so plus f of c minus f of c will get cancelled. Now first I am going to write it the positive, which is f of b, again the negative f of a. Now you know already, if it is f of b minus f of a, you can have write it as integral from lower limit will be a, upper limit will be b, f of x into dx, which is your left hand side. Therefore, we have taken here the right hand side and then we have proved the left hand side, integral a to b f of x into dx. So therefore, you can write integral a to b f of x into dx as adding out the integration of one limit, integral a to c f of x dx plus integral, you can split up that one as c to b f of x dx. I hope you got this one. Now we'll be moving on to the next property, dears. What they have asked, prove that integral a to b f of x dx is equals to integral a to b f of a plus b minus x into dx. Now here, dear students, I am taking here whatever the right hand side, then I am going to try to prove for the left hand side. Now here, let me take the substitution as like this. What they have asked. So let me take the right hand side here. which implies integral a to b f of a plus b minus x into dx. Now here I am going to do the substitution, which like let a plus b minus x is equal to t. Now this I am going to differentiate with respect to x. If I am differentiating with respect to x, you know already the limit, that is a and b are nothing but the limit where they are constant. So constant differentiation is nothing but 0. Therefore, differentiation of a is 0, differentiation of b is 0, differentiation of minus x is minus dx is equal to dt. Otherwise, you can write it as dx will be is equal to minus dt, isn't it? So therefore, if you are doing here substitution method, you have to also change the limit of the function. Now here, let me take it as when x is equals to a. When x is equals to a, what about t? So a, here a minus a plus a will get cancelled. So t will be taking the value b. I hope you understood that one. Now, when x is equals to b, when x is equals to b, here plus b minus b will get cancelled, remaining is nothing but a. So t will be is equals to a. Therefore, you can substitute here, which implies that integral when x is equals to a, t will be getting b. When x is equals to b, t will be getting as a. Now here, f of a plus b minus x I have substituted as t, and then dx I have got it as minus dt. See, I am writing minus outside and dt inside the integral. Now here, according to the second property what we have proved, changing the limit of the function, we can have a minus sign, which will become plus, right? So therefore, changing the limit by property 2, we can have, which implies that minus of minus 1 integral b will be changing as a will be changing as b, f of t into dt. Now minus into minus, which will become plus, which implies that integral a to b f of t into dt. Now dear students, according to the first property, changing the variable, it will not affect the limit of the function. Now you can have, according to first property you can have, which implies that integral a to b, you can write t as x into dx, and this proves your left hand side. So which is the proof of this property. I hope you understood this one, isn't it? So these are all the simple properties you can have. You can keep it in your mind only, or you can remember how to solve by saying the proof itself. We'll be moving on to the next property, dears. Prove that integral, it is not a to b, it is 0 to a. You are having 0 to a f of x dx. Let me write, prove that integral 0 to a f of x into dx is equal to integral 0 to a f of a minus x into dx. Now here, the substitution of the property goes like this. Let a minus x is equals to t. So therefore, differentiating a gives you 0, and differentiate with respect to x. Differentiating a gives you 0. Differentiation of minus x is nothing but minus dx is equal to dt. Otherwise, minus dx is equals to dt. Now you can have here, substituting method, you have to change the variable limit. So here you have to have, when x is equals to 0, see t is equal to a minus 0 is a, and then when x is equals to upper limit a, t will be is equal to a minus a is nothing but 0. So therefore, accordingly, you have to change the limit by taking the right hand side. So right hand side implies that integral 0 to a f of a minus x into dx, which implies that you can have, so f of a minus x, f of when x is equals to 0, you are going to have it as t is equals to a. When x is equals to a, t is equals to 0, right? So f of a minus x I have substituted as t, and dx, it is nothing but minus dt. Be careful dear students, I have taken minus outside the limit. Now here, according to the second property, so by property 2, right? So we can have, which implies that if you change the limit of the function, it will become plus. So a will become 0, 0 will become a, minus will become plus, minus of minus, f of t into dt. So now according to property 1, so by property 1, you can change the variable, the limit will not affect. So therefore you can have, which implies 0 to a f of x into dx. That means putting x is equals to t, dx is equals to dt. So which is your left hand side. And this is a property proof. Same like what you have proved the third property, you are going to prove this fourth property. So next property says that, prove that integral 0 to 2a f of x dx is equal to integral 0 to a f of x into dx plus integral you are having 0 to a f of 2a minus x into dx. So therefore here I am taking the left hand side, dear students. So by taking left hand side, you can have integral 0 to 2a f of x into dx. So by taking the left hand side here, I am going to split up the limit, dear students. 0 to a f of x dx plus a to 2a. Okay, between 0 and 2a there will be a, 0a 2a it will be. So 0 to a and a to 2a. So f of x dx. Now here this is valid. You can see the right hand side. Now I am going to take the right hand side, the second integral. So by taking right hand side second integral, you can have, what is that integral? You are having integral 0 to 2a f of x into dx. But what I want in the right hand side, proof they are asking f of 2a minus x. So therefore here I am going to substitute as let t is equal to 2a minus x. Okay, otherwise you can substitute x is equals to 2a plus, isn't it? So accordingly I am going to substitute here let t is equal to 2a minus x. Otherwise, you can substitute x will be is equal to 2a minus t, because changing the variable limit does not affect here. Now, differentiating with respect to x, you can have dt will be is equal to differentiation of 2a is 0. So, differentiation of dx is nothing but minus dx. Otherwise, you can have minus dx is equal to dt or dx is equals to minus dt. Now, by changing the limit of the variable when x is equals to 0, what is t is equals to 2a. Similarly, when x is equals to 2a, t will be is equal to 2a minus 2a is 0. So, therefore, substituting as well, which implies that integral, so this will become what? When x is equals to 0, t will be is equal to 2a. Similarly, when x is equals to 2a, t will be is equal to 0. So, therefore, you are having 2a to 0 f of, see, x is nothing but if you are going to shift x to this side, t to that side, it will become 2a minus t. So, 2a minus t, dx will become minus dt. Right. So, this can be written as by property 2, changing the limit, it will become positive. So, 0 to 2a f of 2a minus t into dt, right? Now, changing the variable again according to the first property, it can be written as what? It can be written as, which implies integral 0 to 2a f of 2a minus x into dx. Now, taking this one and replacing there. So, 0 to 2a f of x dx can be proved as 0 to 2a f of 2a minus x into dx. That's it. That is a to 2a, right? Okay, let us prove the next property. What is the next property? Says that prove that integral 0 to 2a f of x into dx is equal to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x into dx. Ds, I am taking here the left hand side, then prove the right hand side. So left hand side as 0 to 2a f of x dx. Now by third property, I am going to split up the limit like this. Integral between 0 and 2a, there will be a limit a, 0 to a f of x into dx. Integral 0 to a f of x dx, because between 0 and 2a there will be a, plus integral a to 2a f of x into dx, right? So therefore here I am having 0 to a f of x dx is right in the right hand side. So this we need to change it as, isn't it? So therefore by taking right hand side second integral. So what happens to the second integral? That is a to 2a f of x dx. Now here I am making a substitution. Let x is equals to 2a minus t. Because I want 2a minus x, changing the variable limit does not change. So let x is equals to 2a minus t. Now here you can have differentiating this with respect to x. Dx will be is equal to differentiation of 2a is 0 minus dt. Now you can change the limit of the variable when x is equals to, what is that, a. So 2a minus, that is, you can shift here, you can here write it, t is equal to 2a minus x. Now when x is equals to a, 2a minus a is t is equals to a. Similarly, when x is equals to 2a, isn't it, t will be is equal to 2a minus 2a is 0. So therefore you can have, which implies when x is equals to a, t is equals to a. When x is equals to 2a, t is equal to 0. F of x I have substituted as 2a minus t. Dx I am getting minus dt. Now by property 2 you can change. By property 2 you can change this one as, which implies I am writing it here, minus of minus will become plus. You can change the limit a to 0, 0 to a f of 2a minus t into dt. Now you can change the variable by property 1. So therefore by property 1 you can change this one as 0 to a f of 2a minus x into dx. So therefore you can write 0 a to 2a f of x dx as 0 to a f of 2a minus x into dx. Now substituting here, you can have this, call it as equation 1. So substituting in equation 1, we are having integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x into dx. And this is a property proof. You can have it here, ds. I hope you understood this one. Next property says that prove that integral 0 to 2a f of x into dx is equal to integral 0 to a 2 times of integral 0 to a f of x into dx if f of 2a minus x is equal to f of x, and then this will be is equal to 0 if f of 2a minus x is equal to minus f of x. So this is the next property you are having. Therefore, taking the fifth property, what we have proved. What is that fifth property? Fifth property says that by property 5, you can have integral 0 to 2a f of x. Integral 0 to 2a f of x dx can be written as integral 0 to a f of x into dx plus integral 0 to a f of 2a minus x into dx. Just now we have proved this one. Now here, taking in the right hand side f of 2a minus x as f of x. That's what they have given the condition here. So therefore, in right hand side, if f of 2a minus x is equal to f of x, then this will become what? 0 to a f of x into dx plus 0 to a f of x into dx, which you are going to get it as 2 times of 0 to a f of x into dx. Now here, similarly, when f of x, same in the right hand side, when f of 2a minus x is equal to minus f of x, then you can have right hand side, then right hand side will become integral 0 to a f of x dx minus integral 0 to a f of x dx, which will be equal to 0. And this is what they have taken. That's it. By property 5, you can prove that one. Now we'll be moving on to the next one. Prove that minus a to a f of x dx is equal to 2 times of 0 to a f of x dx if f is an even function and if f of minus x is equals to f of x. Now here, let me take if f of minus x is equals to f of x, right? Now, let us take the left hand side and try to prove out the right hand side. What is the left hand side? Left hand side, they have given it as integral minus a to a f of x into dx is equal to, you can split this one between minus a and a, there will be 0 according to the property 3, minus a to 0 f of x into dx plus 0 to a f of x into dx. Now, 1 f of x dx we got, this we need to change it as 0 to a f of x dx. So, therefore, in the right hand side, by taking the first integral, so in right hand side, by taking first integral, okay. Now, here I am going to do the substitution, let x is equals to minus t. So, dx will be is equal to what? Minus dt. Now, changing the variable. When x is equals to minus a, t will be is equal to minus of minus, which will become a. When x is equal to 0, t is also 0. Right? So, therefore, changing in the right hand side. So, which happens here? Integral minus a. When x is equals to minus a, t is equals to a. When x is equals to 0, t is also 0, f of x is equals to minus t have substituted, dx you are going to get it as minus dt. So, plus this as it is I am writing 0 to a f of x into dx. Now, here by changing the limit, minus sign will become plus, not this minus sign, be careful dear students, outside by property 2. So, therefore, by property 2, you can have a will become 0, 0 will become a, minus will become plus, f of minus t into dt plus integral 0 to a f of x into dx. Now, they have given by changing the variable, limit does not affect. So, therefore, you can have, which implies that integral 0 to a f of minus x into dx plus 0 to a f of x into dx. They have given the condition if f of minus x is f of x. So, by data, f of minus x is equal to f of x if f is even, right? If f is even. So, therefore, we can substitute, which implies integral 0 to a f of x into dx plus 0 to a f of x into dx, which implies 2 times of 0 to a f of x into dx. So, this is what the proof. I hope you got this one. Now, we'll be moving on to the next one. Minus a to a f of x into dx is equal to 0 if f is an odd function, that is if f of minus x is minus f of x. What we have proved in the last case, same proof you are going to do. What we have proved? We have proved that integral minus a to a f of x dx can be 0 to a f of minus x into dx plus 0 to a f of x into dx, right? So by this one, till here, you are going to write the same steps what I have explained, and then you are going to substitute integral. See this 0 to f of minus x is nothing but minus of f of x into dx plus 0 to a f of x into dx. Both negative and positive will get cancelled. You are going to remain with the 0. That's what they have asked you to prove. Understood? This is what the proof. Not only these two steps you are writing, you are going to prove this one, what I have proved in the last property, and then you are going to write accordingly. Understood? Now, these are all the properties they are going to ask you for the proof for 3 marker. Not all the property, any one property they can ask you for the 3 marker, dear students. Now, we'll be moving on to not the first property or the not, you are going to have it as the property 2. From property 3 to property 6, 7, it is very, very important. Understood? Now, we'll be moving on to the problem, dear students. What they've asked, integral 0 to pi by 2 cos squared x into dx. Now, here, I'm going to take it as let I is equals to this one. Okay. So, here, after taking I is equals to, you can have, see, you know, according to the property, I'm writing the property here, 0 to a f of x dx can be written as 0 to a f of a minus x into dx, isn't it? So, this is according to one of the property. So, therefore, by this property, you are changing here a minus x. Here, a replaces pi by 2, 0 as it is. In place of x, a minus x, that is pi by 2 minus x. So, therefore, let I is equal to 0 to pi by 2 cos squared x into dx. Now here I am taking that one, which implies that I can change according to the property 0 to pi by 2, 0 to a, f of means this one, cos squared pi by 2 minus x, isn't it, into dx, because a replaces pi by 2. You know that cos pi by 2 minus x is nothing but sine. So therefore, I can write this one as integral 0 to pi by 2 sine squared x into dx. So therefore, already we have called this one as I. Let this call this as equation 1, and let this, I am going to call it as equation 2. Now here, adding 1 and 2. So adding 1 and 2, I will be is equals to 0 to pi by 2 cos squared x into dx plus 0 to pi by 2 sine squared x into dx. Now this will become 0 to, you can club this limit, 0 to pi by 2 cos squared x plus sine squared x into dx. Now this will become integral 0 to pi by 2. You know that cos squared x plus sine squared is nothing but 1 into dx, which is equal to x from the limit 0 to pi by 2. Integral of 1 into dx is x. Now applying the upper limit minus lower limit, which will be equal to pi by 2. And this is your answer for this question, dear students. I hope you understood this one, where I is nothing but cos squared x into dx. Now here, next problem will goes like this, 0 to pi by 2 integral of root sin x divided by root of sin x plus root of cos x into dx. Same, I am going to take it as let this will be is equals to I. So here, I am going to change according to the property 0 to a f of x into dx can be changed as 0 to a f of a minus x into dx. So therefore, which will be is equal to, implies 0 to pi by 2 under the root of sine, this will become pi by 2 minus x divided by under the root of sine pi by 2 minus x, because a replaces pi by 2, plus under the root of cos pi by 2 minus x. Okay. So let me call this as 1. I am going to call this as 1. I am going to call this as 2. Now adding equation 1 and 2. So I can be written as, what is I will be is equal to 0 to pi by 2, that is under the root of sin x divided by under the root of sin x plus under the root of cos x into dx plus, now dear students, what is sine of 90 minus theta, which is cos theta. Therefore, this you can write it as equation 2 will become 0 to pi by 2. Sine of 90 minus theta is cos theta divided by, again, sine of 90 minus theta is cos theta plus cos of 90 minus theta is here. Cos of 90 minus theta is sin theta. So sin x into dx. So equation 2 will become this. So which implies plus 0 to pi by 2 under the root of cos x divided by under the root of cos x plus under the root of sin x into dx. Now you can combine this limit 0 to pi by 2 under the root of sin x divided by root sin x plus root cos x. So plus you are having root cos x divided by root cos x plus root sin x into dx. Now you can add up by taking the LCM. So therefore you are having 0 to pi by 2. LCM will be root sin x plus root cos x. Now this will become root sin x plus root cos x into dx. Both it will get cancelled. The remaining is 0 to pi by 2. 1 into dx, which is nothing but 1 into dx integral is x from the limit 0 to pi by 2, which is pi by 2 minus 0. The answer you are going to get it as pi by 2. I hope you understood this one. So by one of the properties of the integrals, we have done this problem. So dear students, I hope you understood how to prove the properties of the integral, which is important for your final examination, and then how to solve the problems based on that. In the next session, we'll be moving on to some more problems of solving problems based on those properties. Thank you dear students. Keep watching. Have a nice day.